Okay, well, we're going to start, and we're going to start with P1, which is the first section for protein. I guess as we go through the online portion of the class, I think it's pretty important that you guys do use the course outline. So make sure you look at the objectives, and if you have the book, do the reading. If not, that'll probably be fine, but the reading might prove to be more beneficial in the absence of actual class. It says materials needed. You need some figures. They're from chapter 4 of the book. I posted them online. One of the figures looks like this. Figure 4.1 is basically just the general structure of amino acid, which we'll talk about here in a second. And then there's L and D amino acids, and it basically has to do with the orientation of the amine group. And we're not going to worry too much about that this semester. The other thing that we're not going to worry a lot about is trying to memorize the structure of the amino acids. And so there are 20 common amino acids in animal nutrition, and figure 4.2 has those 20 essential, or 20 amino acids. Not all of them are essential, only 10 of them are essential. And I just want you guys to have it. If you're in biochemistry or plan to take biochemistry, you'll have to learn the structures of those amino acids, but for this semester, you won't have to learn them. So everybody can be excited about that, but you have access to them. So now that you know what you need, we'll go ahead and get started. So protein are basically made of amino acids. And amino acids are to protein what glucose is to cellulose or starch. So we have these 20 base amino acids, and the 20 kind of normal amino acids, and those 20 amino acids plus a few others here and there make up most of the proteins or all of the proteins in your body. So you connect a series of amino acids together, and then that induces a shape, and that creates a protein. And as we've said all along, proteins generally do things in your body. They allow things to happen. Amino acid has a structure, and they all kind of share some components. And so the first thing is they have an amine group. So that would be the NH2 group. They have an alpha carbon, which is this carbon in the center of the molecule. Generally we have a hydrogen. We have an R group, and the R groups are going to differ between the amino acids. So each amino acid has a specific R group, and then we have a carboxyl group. This carbon in the center is the alpha carbon. Okay, so that's the basic structure of an amino acid. The things they have: carboxylic acid, amine group, R group, and a hydrogen. So make sure you keep in mind that all the amino acids for sure have an amine group and a carboxylic acid group. Okay, the essential amino acids. And we'll talk about what makes them essential here in a second. Essential amino acids, there's a device to help you remember them. Matt Hill, VP, or you can do private Tim Hall, or you can do lots of different ones. But Matt is methionine. A is arginine. Threonine. Tryptophan. Then Hill is histidine, isoleucine, leucine, and lysine. And V is valine, and P is phenylalanine. Okay, and essential amino acids have another name. It's more common in human nutrition. Still in animal nutrition, we talk about essential amino acids. Sometimes in human nutrition, you will hear the word indispensable amino acids. So we have indispensable amino acids, and those again are methionine, arginine, threonine, tryptophan, histidine, isoleucine, leucine, lysine, valine, and phenylalanine. And the essential amino acids basically are not synthesized by the body in sufficient, that's an E, in sufficient quantities to meet the animal's requirements. Okay, so the body is basically just incapable of synthesizing enough of these particular amino acids to meet the animal's requirement for those amino acids. The other 10 amino acids the body synthesizes in sufficient quantities to meet their requirements. So when you look at a diet or what the animal's absorbing, they need to absorb these 10 essential amino acids in the correct amounts for them to meet the requirements for them to grow and function properly. So they must be included in the diet at the proper level to optimize. You could use maximize if you want. I like optimize better. To optimize performance. And optimize is probably better because maximization can sometimes be expensive. Non-essential amino acids. Are basically the opposite in that they are synthesized by the body in sufficient amounts. So your body can synthesize these amino acids to a level that you don't really need to consume them in your diet. You still consume them in your diet, but you don't need to. Your body can make them. Okay? Important fact to keep in mind about the essential amino acids is they are still required. So they must be in the body for normal metabolism. It's just that the body can make them. Okay? There's going to be kind of one caveat to this, and that would be on the ruminant side. So we'll put little stars here. Ruminants do not generally require essential amino acids in their diets because ruminal microbes have the capacity to synthesize all amino acids from ammonia and other amino acids. So the ruminal microbes can synthesize all of the essential amino acids, thus providing essential amino acids to the animal. Okay, so you don't have to, ruminant nutritionists don't spend a lot of time worrying, does this diet contain the proper ratio or the proper amount of essential amino acids, because the ruminal microbes are going to change them anyway, going to reform them, and make the essential amino acids anyway. Whereas in pigs and chickens and horses, mainly just pigs and chickens, we spend a lot of time, or nutritionists of those species spend a lot of time really making sure that they've met the essential amino acid requirements for those species. Something to kind of keep in mind, and something that I'll use to challenge you to think about, is they do require, so ruminants do require essential amino acids to be absorbed from the small intestine. Okay, and so this is really important. They have to absorb the essential amino acids because the animal itself can't make the amino acids. They can't make the essential amino acids. The microbes can do it. And the place where we're going to absorb those amino acids is the small intestine. So we do have to make sure the animal has access to sufficient essential amino acids in the small intestine. It's just generally that the ruminal microbes take care of that for us. They're able to synthesize them in sufficient quantities that it generally works out. There's two exceptions, or two common exceptions in ruminants. And these animals, these cattle, so cattle that may require supplemental preformed essential amino acids. And preformed just means that you have to provide them already as essential amino acids. We're no longer counting on the microbes to do it. And the first one is high producing dairy cows. And they require methionine. I almost said methane. They require methionine. And the reason they require it is it's required for the synthesis of milk, fairly high levels of methionine in milk, and we can't get enough microbial synthesis of methionine to meet their requirements. So you will provide a dairy cow, or you can provide a dairy cow with supplemental methionine. And basically what you go and do is you go to the feed store or feed company, if you're a big dairy, they'll deliver it, and you buy a bag of methionine. Now, something that's important about this methionine is the methionine must be protected. Okay, and what we're protecting it from is protected, make that an F, from microbial degradation. So microbes can degrade amino acids, and so if we want to get methionine to the dairy cow's small intestine to meet our methionine requirements, we have to protect it. It has to be protected from microbial degradation. And we'll talk more about microbial degradation in a while, but I really want you guys to spend some time thinking about this and make sure you always have that in the back of your mind as we're studying protein nutrition. The other animal where it's possible is aggressively implanted. And if you don't really have a lot of context for the beef industry, implanted is basically where we give them growth promotants, and so they're implants that we put in the ear, and they increase the rate of growth. They cause increased secretion of growth hormone and insulin-like growth factor, causing the animal to grow more rapidly, improve efficiency, decrease environmental footprint, those kind of things. So if we aggressively implant them, so aggressively implanted steers on pasture. My handwriting was pretty good. Oh, you guys can't see this. That's really bad. Okay, terrible. Terrible. So you're going to have to pause it after you've been really frustrated with me for the last 5 minutes. And you can write this all down. Epic fail. Okay. I'm sorry. I'll try to do better and look at the screen. No one's here to yell at me. I should have one of the kids watch me and they can yell at me. Okay. Anyway, aggressively implanted steers on wheat pasture. The reason wheat pasture matters is wheat pasture doesn't provide a lot of bypass protein, and so, or escape protein, we'll talk about that later. And aggressively implanted, we're increasing their growth, and so when we increase their growth, that really changes their amino acid requirements. So when we look at amino acid requirements, and this is for all classes of livestock, and even people, our amino acid requirements are really dictated by a few things. The major driver is the product produced. So if we're producing wool, we have a set of amino acid requirements, and wool contains a lot of sulfur-containing amino acids, so we're going to have more sulfur-containing amino acids absorbed by the animal. If we're producing muscle, it has an amino acid profile. If we're producing milk, it has a specific amino acid profile. So the product produced is a major driver of the amino acids required. Okay, and so there's a number of things that play into this. And so growth, if I'm growing, that generally increases my amino acid requirements. I'm no longer growing, so my amino acid requirements are less than when I was, say, 20 and still growing. Lactation. If a female is lactating, that increases amino acid requirements. And we can point back to our dairy cow, right? And the more milk she produces, that's why I put the high producing dairy cow. The more milk she produces, the greater her amino acid requirements. Gestation. If you're growing a baby in you, that baby has growth, and that growth requires amino acids, and so you're going to have to consume more amino acids. Puberty, which is kind of tied to growth, increases amino acid requirements. Maturity, like reaching your full body size, would decrease amino acid requirements. You're going to require fewer because you're now as big as you're going to be. So age, independent of weight, we generally decrease amino acid requirements as you age. In humans, they're actually kind of finding that that's generally true until you reach a certain age, and then you should probably increase your amino acid intake to prevent atrophy, or I think it's sarcopenia, which is basically muscle wasting and the loss of muscle mass as you get older. Immune status, relatively timely topic right now, but if you're actively fighting an infection, your amino acid requirements go up as your body gears up the immune system to fight off. Gender. males generally have greater protein requirements than females. There's lots of things that go into this, but this is, if they're the same size, same physical activity, a male will generally have greater amino acid requirements than a female. Another big driver would be weight, how much you weigh. So the more you weigh, the more amino acids you're going to require for maintenance, and maintenance is basically just maintaining the tissues you have, the resynthesis of proteins. Proteins are always turning over in your body, so you need to make sure you provide enough amino acids for that turnover. If you choose to be active / exercise, will increase amino acid requirements. Your species has an effect on amino acid requirements. And then the last thing we're going to put, which is related to all of these, is genetics. And your genetics dictate quite a bit regarding your amino acid requirements. Okay, I'm real sorry about not moving the screen. I'll try to do better in the future. No one's here to yell at me. So, with that, I think we'll be done with P1. We'll do P2 next. Like always, if you have questions, make sure you email me, post something to group me, write a comment in the YouTube, whatever. Just let me know that you have the question and I'll answer it. Generally prefer public questions, that way I can answer them for everybody instead of answering it 250 times. Make sure you do something kind for someone, even if that someone is you.